Hey guys, Dr. Brown here, and tonight we're working the integral of e to the x times square root of 1 plus e to the 2x dx. Hey, what to do with that? Okay, one thing that I observed was you can see that if I let u equal e to the x, matter of fact, let's let, if this is u, e to the x, well, this is u squared. Because if I take e to the x times e to the x, remember the rule, a to the m times a to the n is a to the m plus n. So I add the exponents, that's e to the 2x. So if I let u equal e to the x, u squared is e to the 2x. Okay, so let's take du, that's derivative of e to the x, is e to the x dx. So that's e to the x dx. So du over e to the x equals dx. Okay, so let's kind of fill in the blank here. I've got an e to the x. This is the square root of 1 plus u squared. And I have du, I'm replacing dx here with du over e to the x. Those cancel. So what am I left with? I just have the integral of 1 square root of 1 plus u squared du. Now it's at this exact point that your teacher would want you to recognize that that's a special integral and just say, the answer to that is, you just write it down. Okay? So that's one you need to memorize. But let's work it out. It's no fun. I mean, it's 2:08 a.m. I couldn't sleep. So, hey, let's work a problem. This should put everybody to bed. All right. So, what are we going to do with this here? Well, let's it looks like tangent, right? Okay, I have a squared. I know this drives everybody mad. A squared is 1. A equals 1, square root of that. U equals a tangent theta. Now, we could work that all the way out with the a. Actually, we should, because, I'll show you later. All right, so what do we have here? We have an integral. Let's see, I've got to get a du. It's a secant squared theta d theta. Okay, so we have the square root of a squared plus, if u is a tangent theta, I'm squaring that. That's a squared tangent squared theta. And du equals a secant squared theta d theta. So you know the drill. Let's factor. We've got a squared times 1 plus tangent squared theta times a, I'm going to bring it out here, a secant squared theta d theta. Okay, square root of a squared is a. I'm going to take that to the outside. That becomes a squared. 1 plus tangent squared is secant squared. Square root of secant squared is secant. So I have a squared, the integral of secant theta times secant squared theta d theta, which is what? Secant cubed theta, secant to the third power theta. That also is an integral that you need to memorize. And that equals secant theta tangent, or 1/2 secant theta tangent theta plus 1/2 natural log of the parentheses of secant theta plus tangent theta. Okay? That actually was the integral I was saying you should know from this. So we have the integral of sec a squared times the integral of secant cubed. All right, let's go over here. Let's do a di. I should separate those out. So we're going to do an integration by parts, plus minus. So which term, we're going to leave it separated like this. Which term can I integrate easily? Hey, secant squared. I know the integral of that. So I have secant squared theta d theta. The other piece, I'm going to take the derivative of secant theta. Well, the derivative of secant theta is secant theta tangent theta. The integral of secant squared is tangent theta. Now, you know in the DI method, there's 3 stops. And the stop being you just don't go any farther. Okay, the first stop is in the derivative column. If I keep taking the derivative and I end up with 0, that's a stop. If I find that the terms are repeating, that's a stop. Or if I find a row that I can integrate, that's a stop. And I can integrate that. So I have a squared secant cubed theta d theta equals secant tangent. Sorry for the crack in the board. Right? Life is that way. Sometimes we need to be able to jump over the crack in life. Okay, minus the integral of secant tangent squared. All right, tangent squared theta secant theta d theta. Now I'm going to expand this. Let me do this. A squared integral secant cubed theta d theta equals secant theta tangent theta minus, I'm going to take this tangent squared theta, and what is tangent squared? Secant squared theta minus 1. Now I'm going to distribute this secant theta to the inside. So I have a negative here, minus the integral of secant cubed theta d theta. I'm separating this into 2 integrals. A negative times a negative is a positive. As a matter of fact, I would encourage you, this is something any student that I tutor, I always tell them, get the sign figured out first. Because for me, this is one of my kryptonites. Many times I'll put the negative here and I just won't distribute and I'll just lose it. I'd end up with a negative here, ultimately get the wrong answer. So negative times negative is a positive. Secant theta times 1 is secant theta. Okay, now you'll notice I have, well, a squared is 1. Okay, so that's a 1. I have a secant theta here minus a secant cubed theta and a secant cubed theta here. But if I add a secant cubed theta to both sides, what do I have? I have 2. Well, that's a 1. Okay, I have 2 integral secant cube theta, d theta, and those cancel. So that equals secant theta tangent theta plus the integral of secant theta d theta. Okay. Now I didn't want to know what two integral secant cubes are. I need to know what one is. So I need to divide by 2. So that's 1. So this is 1/2 and 1/2. Now this is another integral that you should know how to work. Okay, you should say, that's natural log of secant theta plus tangent theta. Okay, but let's assume we don't know that. So let's leave our 1/2 right here and just say, what's the integral of secant theta d theta? Okay, I'm going to multiply this by 1, but I'm going to let my 1 be secant theta plus tangent theta over secant theta plus tangent theta d theta. Okay, if I distribute this to the inside, I end up with secant squared theta plus secant theta tangent theta over secant theta plus tangent theta d theta. Okay, if I let u equal secant theta plus tangent theta, the derivative of that, what's the derivative of secant theta? Secant tangent. What's the derivative of tangent? Secant squared. D theta. So this becomes du. So I have the integral of du over u. And that equals the natural log of u, which is secant theta plus tangent theta. Okay, so we can replace that integral with the natural log of secant theta plus tangent theta. Okay, now what are we going to do with that? We're in the theta world. We need to get back to the x world. So let's draw our triangle. That's theta. So we said tangent theta was u over a. U over a. And a was 1. U was e to the x. But for the moment, I'm just going to put it in the u world. This is 1/2 secant. Oh, I didn't finish that, did I? All right, so what do I have? 1 squared plus e to the x squared, which is e to the 2x. And the square root of that. All right, secant then would be the opposite of cosine, so it's this. Let's see, I said I was going to leave it in terms of u. That would be u squared. So secant is the square root of 1 plus u squared tangent theta, which is u over 1, plus 1/2 the natural log of secant square root 1 plus u squared plus tangent, which is u. If you look in an integral table, and by the way, I'd have to divide this a and a squared term into these. you would end up with an a squared down here. So if you look in an integral table for the integral of this, integral of square root of 1 plus u squared du, you will get that. Okay? So I would encourage you to look that up. Now in our case, this a term was 1, so we kind of let it drop out just a moment ago. All right, now then, let's plug in the blanks here for this. We have 1/2 1 plus u squared, which is e to the 2x. And u is e to the x plus 1/2 natural log of 1 plus e to the 2x plus e to the x plus c. And that, my friend, is the integral of e to the x square root 1 plus e to the 2x dx. It's a nice problem. So what tools did we use? We used rules of exponentials. We used trig sub, and we use integration by parts. Wow. Nice problem. But things to remember, the integral of secant cubed, you need to get that in your head. And then the integral of secant theta or secant x, however you want to call it there, those two integrals, they seem to come up a lot. So you should be able to say, the integral of secant cubed, that's 1/2 secant tangent plus 1/2 natural log secant plus tangent. Okay, all right. Why are we doing this? Together, we're trying to build a better tomorrow and do that through math. Keep studying, and that's all for now. We'll talk to you next time. Thanks.